This pre-calculus lesson has to do with rationalizing denominators and numerators. Start off with something you've seen a little bit of before, and that is rationalizing the denominator. If I have something like this, 5 over 2 root 3, the term rationalize just means to make rational, to make the denominator so that there's not a square root 3 in it. And so what I do is I multiply by the square root of 3. To do it without changing the value of this fraction means to do it on the top and on the bottom. The numerator becomes 5 root 3. That's not rational. But the good news is at the bottom will be 2 times the square root of 9, which ends up being 5 root 3 over 2 times 3, which is 6. Fraction doesn't reduce, and so you're done. If you try this on your calculator, 5 times root 3, and divide it by 6, it'll give you the exact same horrendous looking decimal as you got when you did 5 divided by 2 root 3. So you can see that you haven't changed the value of the fraction, you've just changed what it looks like. This next one, we're given a slightly more complicated example because the denominator doesn't just have a single term in it. It's got 7 minus root 5. If you make the mistake of just multiplying by root 5, you'll realize, oh no, my denominator isn't rationalized. The way that you do get rid of this is you multiply by what's called the conjugate of the denominator, and you do need to do it on the top and on the bottom. On the top, you may or may not decide to expand that out, FOIL it out. It doesn't really look any better if you do, so you might as well just leave it as it is. But the bottom will be significantly better. 7 times 7 is 49. If you FOIL it, you completely have plus 7 root 5, but then you have minus 7 root 5, and then you have minus root 25. And so, again, the numerator, feel free to expand it if you like, but it'll just turn into a bunch of terms with square roots in them. Nothing simplifies. But on the bottom, these middle two terms go away, and you end up with 49 minus 5, which is 44. Next example here is the first one that kind of steps away from something you've seen in high school, and that is, to this point, you haven't had to rationalize denominators that had something like root x in it. Really, the steps are the same. I don't want to have a square root of x on the bottom, so I'm going to multiply by root x over root x. On the top, you again have the choice of multiplying that through or not. In this case, maybe I will. I'll have 7x to the 5 over 2 minus root x, or x to the 1/2, over root x times root x is just x. So, followed the instructions, rationalized the denominator, ended up with not a pretty looking situation, but at least the denominator is not irrational. This next one's a little unusual because we're asked to rationalize the numerator. Probably never had to do that in Math 10 either, but the fact is we really need to follow the same type of steps. In this case, we have more than one term in the numerator, so to rationalize it, we're going to need to multiply by its conjugate, meaning all I do is put a minus in the middle of the two terms. I do need to do it on the top and on the bottom. And so my denominator is not going to end up looking all that pretty, but let's look and see what happens on the top. Root x minus 4 times root x minus 4 just equals x minus 4. The middle terms will cancel out, and I'll end up with minus square root of x plus 2 times square root of x plus 2 is x plus 2. On the bottom, it's definitely not worth trying to multiply the x through here. Just leave it as x times the square root of x minus 4 minus square root of x plus 2. The numerator here, though, does simplify fairly significantly in that x minus x is 0, negative 4 minus 2 is minus 6. So the numerator definitely is rationalized, which was the purpose of the step, and you end up with an expression that looks